Alice. So I get what the benthos is now, but how did it all get here?
Well, there's different ways that the sediment and benthos can come, and one of the main ways that it can come is from the land. So that's called heterogeneous sediment. So things like erosion from modifying the land through farming and other or urban development.
Okay. What about all these shells and things living in here?
It's biogenic, so it means it's coming from something that was living. So the shells, bones, things such as fecal matter, that can all make up a different kind of sediment. And that's the second most common. There's also two other ways that you can get sediment to come to the benthos. One of that is cosmic. So where do you think that comes from?
Is that like space?
Yeah, so space dust and meteorites and meteors, that's where that comes from.
So some of the sediment sources literally fall from the sky.
Yep.
Wow.
And then the other one, which again isn't that common, is called hydrogenous. So where do you think that might come from?
I know hydro's like water, so you have pointed out this creek.
So close, yeah, it's to do with water, but it's more to do with the chemical reactions that occur in the water.
So like pH?
Yeah, definitely.
Cool. So here we have a topographical map of the seafloor showing the area around New Zealand. So we have the South Island here and the North Island here. And then all of this coloration here is actually what is the seafloor surface. And so it gives us a view of different depths. So we can see this red color is going to be a bit shallower, and then it moves on to the deeper purples down here. But it's pretty evident from these different colorations that you can see ridges along here and trenches. If you look really closely here, different channels of these submarine activities happening. And along here we have really steep changes, and so we have this tectonic plate action that we know about here, and then this really cool seamount where there's some volcanic activity happening.
So these changes over time can be recorded in the sediment record. So as you can see from this cross-sectional model here, there are different layers in the sediment as you go further and further down. So like what we did on the intertidal with the small core, people can go down and drill down through that column and get a much larger core and then bring it up and then start to date those different layers over time. The topography of the seafloor, along with the water currents and even the type of sediment, can determine where it settles. But sediment doesn't remain settled in one place forever. So even sediment that's down at here, or part of the benthos, can get risen up to the top of the seafloor and even above through geologic processes. So if we come back round to our topographical map here, we can see that there's the Indo-Australian plate here and the Pacific plate here. So the Pacific plate subducts under the Indo-Australian plate, and that creates this really strong ridge that you can see on the seafloor and even above, which is the Southern Alps. So everything that makes up those mountains here is actually part of the benthos, so it was once part of the seafloor. And that can happen over time, and a really good recent example of this is actually up here in Kaikoura with the earthquakes that happened here. And some of the benthos from underneath the water actually rose to about, in some places, 5 meters above sea level. So some other environments where we can see evidence of the change from the seafloor benthos up into land is through sandstone and mudstone, which are terragenous sediments, and then also limestone, which is an example of biogenic sediment. So we're going to go have a look at an example of a fossil that's been preserved in some limestone from North Otago. So this fossil is a well-preserved skull of a shark-toothed dolphin, which was found in the biogenic sediment of the limestone, which is well known in North Otago. So this sediment was from the benthos about 24 to 25 million years ago. So it's taken a really long time to come up, unlike the seafloor that we talked about earlier with the Kaikoura earthquake, which happened really quickly in a one-off event. Another example of a biogenic sediment is actually this block here. So this is from North Otago as well, and there's lots of different things here which have been exposed for us to look at, and it gives us so much information about what kind of things were living at that time, millions and millions of years ago. So you can see there's some large tube-like structures and big shells, but what's probably even more important is all the microscopic bits of plankton and little tiny fragments that you can see here that make up this block. So these tiny fragments are often Coccolithophores or Foraminifera, which make up this ooze that you can find on the bottom of the seafloor called Calcareous ooze. And this is often located closer to the land masses, so near the continents. There is another type of ooze that you'll find on the seafloor, and that's called Siliceous ooze. And this is often found deeper, so in the ocean basins, such as the Pacific Ocean. And this is made up of primarily diatoms and radiolaria. So the reason that these two types of oozes aren't found in the same areas is because of this thing called the calcium compensation depth, or the CCD. And this is when the rate of the accumulation of calcium and the rate of the dissolution of calcium are equal. So basically, once you get to this depth, which is usually about 4 or 5 kilometres deep, the calcium gets dissolved and it can't settle down on the places of this depth. So that's why you find the two oozes in different places.
By now, we have a pretty good idea of what this map of New Zealand looks like here at the South Island, and how the prevailing currents are moving around it, and how these currents are affecting the benthos, but they also have ecological implications. And so, over here we have a view looking southwest into the Otago Harbour. The New Zealand Marine Studies Centre is right about here, and this is kind of the halfway point between the inner and the outer harbour. And so we can see this channel right here. This is kind of a lower tide in this image, and this is the channel where the ships run through. And we have the Air Moana Mole out here at the end. Outside the harbour, we have the nice rocky coastline where there's some different communities and ecological systems out there. And we have the estuary where Papua Nui Inlet and Hooper's Inlet down over here. So if we look at this other diagram showing a little bit more of the area and moving a little bit farther north into East Otago, the area I work up here near Karatane that has the nice rocky shoreline along here, but it's also sand in there, especially down here in Blueskin Bay, that there's lots of different habitats and critters that live there. So things like seaweeds that I study, that they live along the rocky shoreline. Some of those actually don't live on the benthos that are here in the sandy Blueskin Bay. You'll find other different kinds of seaweeds or life living there. And so as you move further out, you'll see right here this gyre kind of circulates in there, kind of depositing some mud, but also the prevailing current is bringing in all this relic sand and gravel that continues moving up north, and different sand from animals and shells and skeletons. As we move further out along the shelf, we have these rocky canyons that lots of different things going on there, but it continues moving out deeper into the muddy, deep benthos. As students and as scientists, we want to sample and take a look at these different things happening out here that have ecological implications. And so to measure those things, we have lots of different tools that we can use and ways to see the changes that are happening in our waters.